The openness of an unblemished exoplanet has stargazers connected with that it could be for sure incidental effects and signs and side impacts of something happening on a more significant degree. For a genuinely gigantic time span, the dream around finding lifestyles beyond Earth has captivated humankind. On account of the James Webb Space Telescope, that dream may moreover need to in a while reconsider into a reality. The telescope has uncovered a charming spine chiller in Proxima Centauri, the closest colossal name structure to us. Amidst its PL Proximus B stands segregated with odd fake lighting leaving the sober-minded neighborhood. Should this be the broad expected affirmation of sharp lifestyles past our planetary social occasion? How do scientists select assuming the one's lights propose the presence of sharp presence on Proxima B? Oblige us as we take off into how the James Webb Telescope just seen city lights 7 trillion miles from Earth. Individuals have interminably been truly curious around the special bits of knowledge of the universe. Mechanical kinds of progress are common ability to explore the Earth and sky stay aware of to push us after a large wide sort of tremendous stretches of improvement. Earth stays the key planet that we comprehend to have life in that capacity. The deeply grounded question drives forward. May we are revealing where the fundamental inhabitants of the universe, or on the other hand, are their metropolitan foundations consolidated a part of the stars basically for slowing down for us to track down them? To find the response to this intricate interest, two American cosmologists, Jill Tarr and Thomas Pearson, were given going an attempt called Excursion for Extraterrestrial Data, SETI, in 1984. This non-income-driven TR trusts to channel through vast district focusing on spaceborne radio transmissions. These radio waves are facilitated for visiting gigantic distances and are the central procedure for anticipated extraterrestrial correspondence. To the Forstall 42 radio telescopes saw in the focal point of the Californian flood mountains were carefully tuned to the frequencies of the universe. These radio telescopes, called the Allen Telescope Show, were needed to get any parasitic sign from space. In spite of the reality that specialists have taken a gander at the sky for solid proposals cut off a lengthy time span, until the specific moment, there is no convincing affirmation in regards to signal originating from a distant human headway. Not gets through late AUD from NASA suggested that the James Net Space Telescope, JWST, could moreover have seen counterfeit city lights from adjacent planets. Is there any substance to this? May we kind out the fruitful dispatch of the James Webb District Telescope as humanity's Goliath step forward in covetous the universe? The JWST is the most evolved device inside the certified visible past of humankind to see the value in what the universe holds. Composed around 1 million miles from Earth, this Goliath telescope is our window to the earliest seasons of the universe. It brings the at this point direct understanding centered and closer, revealing information into the method of advancement of designs, stars, and planets. Stargazers outfit the JWST with best-in-class cameras and channels to get besides examine the huge tones consolidating splendid articles. Through JWST, examiners are prepared to part and convey together essential records about the substance plans and actual homes of first rate are our bodies in the farthest reaches of the universe. They achieve this through isolating unequivocal frequencies of light. Beyond fundamental feeling, JWST inspects and explores the replacements to exoplanets for sorts of presence. Its unmatched capacity to appearance past the rules of truth has prompted the out-and-out most wonderful divulgences. An event through the telescope stargazers have chosen extra mass than at present alluded to exist inside the universe and some 428 at 8,651 universes. This finding has explored in cutting-edge considerations concerning the organization and levels of the universe. With humankind deciding to explore the farthest scopes of the universe, the JWST may be a critical machine in settling the secrets of secluded universes and getting ready for flawless astrophysical data simply and over the top number of early by a long shot. The spot beyond our planetary design remained for the most part dull and with practically no trace of known planets. Anyway, cosmologists have seen that revealed more than 4,000 exoplanets circumnavigating far-off stars, a setting exhibit of human development and mechanical improvement. As per NASA, this stock can similarly mean the downfall of the superb ice, displaying the presence of trillions more exoplanets scattered all through the universe. Inside the searing test for extraterrestrial presence, experts stay aware of to impression inside the course of the likelihood of seeing outsider neighborhoods previous where we had been now. As destiny would have it, During the Galileo rocket's trip to Jupiter, its spectroscopic device out of nowhere uncovered a particular heavenly etching that affirmed organic vegetation. This basic disclosure marks at something point specialists, regardless of anything else, have considered to be a biosignature. The plant's purple part VRE takes a gander at unimaginable methods of life undeniably through focusing on the way it reflects moderate. Through the virtue of JWST uncovering, the solicitations of extraterrestrial conditions are ordinary. It will do this utilizing cautiously coordinating, similarly as conceivable, of perhaps sensible and broadened way off more prominent sun planets. Tracked down in the substantial zones on the point while seeing those V signs and secondary effects may be sizable confirmation in the excursion for sharp presence. Outside our planet, it might be the beginning of one more association for us in our errand to see as the privileged insights of the universe. As daylight hours travel through the natural layers, the secluded slight which conveys outstanding frequencies is absorbed through the rubbish and iotas in these layers. This INIST achieves a normal great model as prohibitive fingerprints that may be deciphered through spectroscopic IPC appraisal. It's like-sized that at the point when light from a superstar illustrates up at a planet, the JWST will really have to get it since it enters the planet's present-day situation. In the end, the JWST should be the best way to deal with uncovering the natural plan of a way of exoplanets, an essential indication of their real potential for natural methods of life. Earth, Goliath planets, straying whether it's rich in oxygen, nitrogen, what's more, carbon dioxide like Earth, ought to stay aware of conditions supportive for lifestyles, to the extent that we would be concerned. Notwithstanding the deficiency of expected parts or the presence of unforeseen blends, ought to interpret secondary styles of lifestyles, life, or without a doubt, even mechanical inclinations. Extremely found chlorofluorocarbons, CFCs, which can be man-made compounds often applied for refrigeration and current components, should help science in showing the presence of an extraterrestrial human headway. Assuming the JWST observes such fake particles inside the attitude of EX planets, it'll open new steady regions for extraterrestrial turn of events. Outside our planetary get-together, this addresses a truly interesting challenge for colossal experts starting one more entry into the climatic underpinnings of arranged universes and the chance of top-notch human progressions. Far beyond the straightforward way, the exposure generally present beyond our planet is portrayed by a few entryways that stream past the principles of intrinsic mechanical expertise. Even though we each sometimes envision life as succeeding in quiet conditions like our own, exceptional reality it could show clearly more moved and ridiculous. For example, if extremophiles, an enchanting get-together of creatures overwhelmingly made from microorganisms, challenge what we grasp as a sensible dwelling region. These advantageous dwelling matters can without masses of a stretch make do, on the other hand, even flourish in conditions that are all things considered portrayed as exceptionally superfluous. Extremophiles can persevere through even the most threatened conditions with temperatures up to 250 degrees Fahrenheit and pH levels under 3. They are the first-rate instances of the force of standing issues under hard conditions. Likewise, the interminable factors of the universe and the boundless conditions related to it lead us to catch that our trip for extraterrestrial lifestyles needs to be huge. In spite of the fact that the reference planets appearing to be Earth-like and surrounding round stable sun-like stars convey genuine anticipated open doors, we truly need to AIT, on the other hand, open conditions top open doors for evaluation. May likewise need to contain exoplanets circumnavigating red little stars which might be more plentiful in the universe. At any rate, their weakness and cooler temperatures stood out from our sun. These stars offer top-notch open doors to break down the capacity for lifestyles in different models. The drawn-out future of red little stars offers an adequate risk for the consistent jumbled kinds of lifestyles rise and improvement to spread out AR changed basically for decimeters a very lengthy corridor from Earth. The TRAPPIST-1 planet Air's framework tempts as an amazing comprehension for the James Webb District Telescope, JWST undertaking. This brilliant construction, including an unprotected red little genius and 7 Earth, limitless inconvenient planets, circles the serene red little star. 3 of those dissected planets are implied as nice planets and may in all open door have water on their surfaces. No matter what reality, it is more humble and cooler than our sunlight-based. The TRAPPIST-1 megastar exudes touchy and Earth-like slight that is sensible for supporting life on its circling planets. Most of the various stars in the right normal neighborhood Proxima Centauri arise as a wellspring of viewpoint normal for likely a distance of genuinely 4.25 ma long time from the sunlight based. The base makes Proxima Centauri the nearest colossal name to our classified. This enormous call ought to be found in its weak sparkle. It is honestly barely visible inside the center of the dinking of the night sky. Not persevering through its weak quality, it implies that any nice planet circumnavigating it should keep a nearby distance. The entire of any substantial planet to Proxima Centauri ought to be to some degree more than various times nearer than Earth to the sunlight based. Without pleasurable thing, the circumstance, none of its planets can keep up with presence-helping conditions with adoring our planet. The examination of exoplanets has opened a colossal wild by the way we could decipher the universe. With types of progress in development and flexible limits, space specialists have perceived a large number of exoplanets revolving around faraway stars. Every disclosure reveals one more piece of the riddle, uncovering understanding into the different and multifaceted design of planetary structures past our own. Among the most fascinating centers for study are red little stars, which are the most notable kind of star in the smoothway universe. These stars, more unassuming and cooler than our sun, offer unique opportunities to search for conceivably reasonable universes. Paying little mind to their lack of clarity, red little individuals can have planets in their reasonable zones where conditions may be proper for liquid water to exist on a shallow level, an essential necessity for life. The TRAPPIST-1 framework, for instance, got the thought of specialists overall while clutching 7 Earth-sized planets, 3 of which circle inside the star's legitimate zone. The closeness of these planets to their host star raises issues about their potential for reasonableness and the presence of life-supporting conditions. In the mission for signs of something happening under the surface past Earth, scientists use a collection of strategies, counting spectroscopy, to separate the heirs of exoplanets. By focusing on the substance course of action of exoplanet environments, experts can accumulate the presence of key atoms like water fume, carbon dioxide, and oxygen, markers that could propose the presence of life. The James Webb Space Telescope, JWST, equipped to agitate our appreciation of the universe, certifications to expect to be a critical part in the examination of exoplanets. Equipped with best-in-class instruments, the JWST will investigate the conditions of faraway universes, searching for snippets of data to their conceivable reasonableness and the presence of life. Beyond the journey for Earth-like planets, space specialists are similarly charmed in focusing on silly circumstances that push the cut-off points of what we consider valid. Extremophiles, animals prepared for squeezing by in brutal conditions, challenge how we could decipher life's adaptability and flexibility. By examining extrema on Earth, analysts gain experiences into the potential forever to exist in apparently obnoxious conditions elsewhere in the universe. As our development and appreciation of the universe keep on moving, the search for life past beyond Earth will keep on evolving. Each new disclosure, whether it's a far-off exoplanet or a novel extremophile species, adds another part of the riddle of our astronomical beginnings and our spot in the universe. Delving deeper into various aspects of exoplanet exploration, the search for extraterrestrial life, and the implications of such discoveries could significantly lengthen the content. Here's an extended version. The exploration of exoplanets, planets orbiting stars outside our solar system, has emerged as one of the most exciting frontiers in astronomy. With advancements in observational technology and data analysis techniques, astronomers have identified thousands of exoplanets, each offering unique insights into the diversity and complexity of planetary systems beyond our own. One of the primary objectives in the study of exoplanets is the search for signs of life beyond Earth. While the existence of extraterrestrial life remains a matter of speculation, the discovery of habitable exoplanets, those with conditions suitable for life as we know it, has fueled scientific curiosity and public imagination alike. The James Webb Space Telescope, JWST, poised to become a game-changer in the field of exoplanet research, promises to revolutionize our understanding of these distant worlds. Equipped with state-of-the-art instruments capable of detecting subtle atmospheric signatures and characterizing planetary compositions, the JWST holds the potential to identify potentially habitable exoplanets and even detect signs of biological activity. One of the key strategies employed in the search for life on exoplanets is the study of their atmospheres. By analyzing the chemical composition of exoplanet atmospheres using spectroscopic techniques, astronomers can identify molecules such as water vapor, carbon dioxide, and oxygen, essential ingredients for life as we know it. The presence of these molecules, particularly in combination with other biologically relevant compounds, could serve as strong indicators of habitability and the potential presence of life. However, the quest for extraterrestrial life extends beyond the search for Earth-like planets and familiar biomarkers. Scientists are also exploring the concept of weird life, forms of life that may exist in environments drastically different from those found on Earth. These extremophiles, organisms capable of thriving in extreme conditions such as high temperatures, acidic environments, or high-pressure environments, challenge our preconceived notions of habitability and broaden the scope of potential habitats for life in the universe. The discovery of extremophiles on Earth has profound implications for astrobiology, the study of life in the universe. By demonstrating the adaptability and resilience of life in harsh environments, extremophiles offer tantalizing hints about the potential diversity of life forms that may exist beyond our planet. From deep-sea hydrothermal vents to acidic hot springs to the frozen wastelands of Antarctica, Earth's extremophiles inhabit a wide range of environments, each providing valuable insights into the limits of life's adaptability. In the search for extraterrestrial life, scientists are also exploring alternative biochemistries, forms of life that may use different molecular building blocks than those found in terrestrial organisms. While life on Earth is based primarily on carbon chemistry, researchers are considering the possibility of alternative biochemistries that rely on different elements such as silicon, nitrogen, or sulfur. By expanding the search criteria to include a wider range of chemical possibilities, scientists hope to cast a broader net in the hunt for alien life forms. Another intriguing avenue of research in the quest for extraterrestrial life is the study of biosignatures, indirect evidence of life that can be detected from a distance. Biosignatures can take many forms, including atmospheric gases produced by biological activity, distinctive patterns of surface reflectance, or even the presence of complex organic molecules. By identifying these telltale signs of life, astronomers can infer the presence of biological activity on distant exoplanets and prioritize targets for further study. The detection of biosignatures requires advanced observational techniques and sophisticated data analysis methods. In recent years, astronomers have developed increasingly sophisticated models and algorithms to simulate the atmospheric conditions of exoplanets and predict the detectability of potential biosignatures. By combining observations from ground-based telescopes, space-based observatories, and future missions such as the JWST, scientists hope to build a comprehensive picture of the habitability and potential for life in our galaxy and beyond. However, the search for extraterrestrial life is not without its challenges and uncertainties. Despite significant advancements in technology and observational capabilities, the detection of biosignatures remains a complex and challenging endeavor. Many factors can complicate the interpretation of observational data, including atmospheric variability, instrumental limitations, and the presence of false positives. Moreover, the existence of extraterrestrial life raises profound questions about the nature of life itself, its origins, and its prevalence in the universe. Are we alone in the cosmos? Or are there other intelligent civilizations out there waiting to be discovered? The answers to these questions have far-reaching implications for our understanding of our place in the universe and our relationship to other potential forms of life. In addition to searching for signs of extraterrestrial life, astronomers are also studying the formation and evolution of planetary systems to gain insights into the conditions that give rise to habitable worlds. By observing young stars and their protoplanetary disks, researchers can trace the process of planet formation from the early stages of dust and gas clouds to the formation of fully formed planets. This research provides valuable context for understanding the prevalence of habitable environments and the likelihood of finding life beyond Earth. Furthermore, the study of exoplanets offers unique opportunities to test theories of planetary formation and evolution. By comparing the properties of exoplanets with those of the planets in our own solar system, scientists can refine their models of planet formation and gain insights into the diversity of planetary systems throughout the galaxy. From hot Jupiters to super-Earths to mini-Neptunes, the diversity of exoplanets challenges our preconceptions and expands our understanding of planetary science. In conclusion, the exploration of exoplanets and the search for extraterrestrial life represent some of the most exciting and challenging endeavors in modern science. With the advent of new observational technologies and data analysis techniques, astronomers are poised to unlock the secrets of distant worlds and potentially answer one of humanity's most profound questions. Are we alone in the universe? Whether we find signs of life on distant exoplanets or not, the journey of discovery promises to expand our understanding of the cosmos and our place within it.